Let's look at this one. So it says, is X a north or a south pole? Remember, I said now, when you push in the magnet, so from the previous video, this is what we said. This is what we discussed. Okay, from the previous video, we discussed the fact that when you push in the magnet, you are putting in the north pole. Therefore, the solenoid will create a north pole so that it repels the magnet. Because when you push in the magnet, the solenoid wants the magnet to go out. But when you pull it out, now it wants it back. It wants to come back. It wants it to come back. Right. So I said whenever you are pushing in, the bar magnet, the poles will be the same. Then when you pull out the magnet, then the poles will be opposite. So here we check, we realize that if I pull out the magnet like this is going away, it means I am pulling out the north, right? I said you focus on the north. So you pull out the north. When you pull out the north, the solenoid will create a south pole so that the north comes back, because when you pull it out, it wants it back, right? So I say out, opposite, out, then opposite pole. So when you pull out north, it will create an opposite pole, which is south. But when you push in, and we're pushing in the south, then it will create the same pole, which is south, so that it repels it. So that's what we discussed in the previous video. All right. So let's look at this one now. We want to know whether X here in front of the solenoid is going to be positive or negative, right? So X is a point that is in front of the solenoid. We must take note of that. So when you push in, the poles will be the same. Then when you pull out, the poles will be opposite. Out, opposite poles. Right. So now what are we doing? We are pushing in. What are we pushing in? We are pushing in the north. When we push in the north, then the solenoid will create a north pole, because I said in same pole. The reason is because it wants to oppose the change. The induced current is trying to oppose the change in magnetic flux. Okay, so that's the reason why this is happening. Right. So meaning this is the north pole, and therefore this is the south pole of the solenoid. Now, after knowing the north pole and the south pole of the solenoid, Now they say, is the direction of the current from A to B or from B to A? So for you to know the direction of current, you must first know what are the poles around the solenoid, not really necessarily the ones in the bar magnet, but you must also know the ones that are in the what, in the solenoid. What are the poles, whether it's north pole or south pole? All right. Yes. Now, number two, what are we going to do? We are going to we're going to do this. We're going to identify the front wire. This is the front wire now because it's continuous. Okay. And this is the back wire. This is the back wire. Right. And now I point with my thumb. I take my thumb. I point in the direction of the north. Okay. Then you curl your fingers like this. You curl your fingers. You see, in front is like you are seeing, you can be able to see your palm, you know, you can see the palm, the part that is kind of yellowish, or okay, the one that is this the palm. You almost see the palm. Together with your nails, you can see your nails. Okay, yeah, let me put it like that. You can also see your nails here. These are your nails, you can see them. Yeah? Yeah, these are your nails, you can see them like that. So now you are pointing in the what? In the direction of north with your what? With your thumb. Then you curl your fingers. When I say when you curl your fingers, you see these are your nails. Your nails are pointing down in front. Ne? Your nails in front are pointing down, which means the current in the front wire is pointing down. The current in the front wire is pointing down. So whatever is happening in front is what will happen to the front of the wire. Okay. Whatever is happening in the front of your hand, what you see in the front of your hand is what will see what happen so in the front wire. Okay. Yeah. So now where to it means now if the front is going down like this, then the back is going up. So now we can see that the current is from A up to what? Up to B. So the direction of current is from A up to B in this case.